We flip a switch, and a room just fills with light. We tap on a screen, and the entire world is right there in our hand. Electricity. It's this invisible force that powers pretty much everything in modern life. But for most of us, it's still kind of mysterious, right? We use it every single second, but what is it? What is this juice that runs our world?
You know, this reminds me of a great story. A physics professor once asked an engineer about the electric motor he was running. The professor starts going on and on about ohms and amperes and volts, but the engineer just kind of looks at him, totally blank, and says, "Look, all I know is to turn on the juice and let her buzz." And let's be honest, that's most of us, isn't it? We're totally comfortable using the juice, but the actual science behind it, it feels like a kind of magic.
So that's the big question we're going to tackle. What exactly is this juice? To find out, we're going to take a trip back in time. We're going to trace the path of discovery from this ancient curiosity all the way to the engine of our modern world.
All right, so our journey starts in the ancient world, where the very first hints of these strange forces were noticed. And for thousands of years, nobody thought they were related at all. I mean, one was like a weird party trick, and the other was this mysterious stone that could pull iron towards it.
Now, what's absolutely wild here is the sheer amount of time we're talking about. Back in 600 BC, the Greeks knew that if you rubbed a piece of amber, which is elektron in Greek, by the way, it got this strange power to attract things. And around the same time, they knew about magnetic lodestones. But just look at that gap on the timeline. For more than 2,200 years, basically no progress was made. It wasn't until the year 1600 that a guy named Dr. William Gilbert finally decided, okay, let's study these things seriously.
So how did they even start to figure this out? Well, here's a really brilliant early theory of magnetism from our source, Elisha Gray. He said that magnetism isn't something you add to iron, it's a property that you unlock. Imagine that in a normal piece of iron, all the tiny molecules are paired up in these little closed rings. Their magnetic forces are just pulling on each other, totally satisfied and contained. But when an outside force comes along, it breaks those rings and it yanks all the molecules into a line, so they're all pulling in the exact same direction. And all of a sudden, their combined force can reach outside the iron and start attracting other things. Pretty cool, huh?
For centuries, electricity was just that, static cling from rubbed amber. But in the 18th century, one of the most famous experiments in all of history would prove that this tiny little force was also behind one of nature's most awesome and terrifying displays, lightning. So picture this. It's June 1752, and Benjamin Franklin is getting tired of waiting for a tall church spire to be built for his experiment. So he gets creative. He makes a kite out of a silk handkerchief, attaches a sharp wire to the top, and ties a metal key to the string down near his hand. He flies this thing into a storm cloud, very carefully holding a dry silk ribbon to make sure he doesn't get electrocuted. And as the rain soaks the kite string, making it conductive, he was able to draw sparks right from the key, proving a direct link between the storm raging above and the electrical force he could make right there on the ground.
What Franklin did was massive. He ripped the mystery away from lightning. It wasn't some supernatural act of the gods. It was just a giant version of the same static electricity people had been playing with for centuries. And this understanding led him directly to invent the lightning rod, which has saved countless buildings and lives by, well, taming that divine fire.
Okay, so Franklin connected static electricity to lightning. Awesome. But the next great leap forward came from a truly bizarre place. A kitchen accident in Italy in 1790 involving a dead frog. Yeah, and this completely accidental discovery would reveal a whole new kind of electricity.
So here's what went down. Luigi Galvani's wife was prepping frogs for soup. She noticed that when a scalpel that had touched an electric machine also touched a frog's leg, the leg kicked. Galvani was totally fascinated, and he came up with this theory of animal electricity, some kind of life force inside the creature itself. But another scientist, Alessandro Volta, he had a different idea. He thought, wait a minute, I don't think it's the frog. I think the kick is coming from the reaction between two different metals and the moisture in the frog's leg.
And to prove he was right, Volta created this thing, the voltaic pile. He stacked up discs of copper and zinc, and he separated them with cloth that he'd soaked in salt water, and when he connected the top and the bottom, boom! It produced a steady, continuous flow of electricity. It was the world's very first battery. And this was a total game changer. For the first time ever, scientists had a reliable, on-demand source of electric current they could actually experiment with.
The author of our source material, Elisha Gray, gives us this wonderful personal story about this invention. As a kid, he was obsessed with making things he read about in books, so he built his own voltaic pile.
He got the copper from the bottom of his mom's wash boiler and the zinc from under the stove. And he said, I shocked my mother twice, first with the voltaic pile, and again when she found out where the metal plates came from. You gotta love it.
So, we've got lightning, we've got static, and now we've got current from batteries. But magnetism was still seen as this totally separate thing. The final, critical piece of the whole puzzle was put into place by the brilliant English scientist Michael Faraday, who discovered the deep, unseen connection between them.
What Faraday found was just mind-blowing. He discovered that if you simply move a magnet near a coil of wire, a little electric current just appears in that wire. No battery, no rubbing, nothing. Just motion and magnetism creating electricity out of thin air. This is called electromagnetic induction.
But here's the kicker. He then found that the relationship worked both ways. If you run an electric current through a wire, it creates a magnetic field around that wire. So it's a two-way street. A moving magnet makes electricity, and moving electricity makes magnetism. They weren't separate at all. They were two sides of the very same fundamental force. And right there, in that simple little experiment, was the seed of our entire electrical world. It was the germ of the dynamo, the electric generator. And this is the principle that powers every single power plant on Earth today. Doesn't matter if it's a turbine spun by steam, or water, or wind, it's all just moving a magnet near a wire to create a powerful, continuous flow of electricity.
And this just shows you how things started to move at, well, lightning speed. From that first observation by Thales all the way to Franklin's kite took 2,300 years, a huge amount of time. But from Franklin to Volta's battery, just 48 years. And from Volta to Faraday finally uniting electricity and magnetism, only 32 years. Each breakthrough gave scientists the tools for the next one, setting off this incredible cascade of innovation that would completely remake the world. Because once these basic principles were finally understood, the application of this new power just exploded, fundamentally changing everything about how we live, how we work, and how we talk to each other.
Just think about it for a second. Before all this, the world was a vast, vast place. News could only travel as fast as a horse or a ship. But with this new understanding, humanity began to thread the planet with what Elisha Gray called iron nerves. Suddenly, we had the telegraph, the telephone, electric lights turning night into day, electric trolleys. All of these modern marvels grew directly from the patient, brilliant work of these early pioneers. They shrank the globe and literally built the world that we now take for granted.
And so, we're going to end with this thought from Elisha Gray, written over a century ago, but it's just as true today as it was then. Where it will all end, no one knows, but that it has ended, no one believes. From a piece of rubbed amber to the global network that's in your pocket right now, the journey of discovery keeps going. The juice is still full of mysteries, and who knows, the next great breakthrough could be just around the corner.